Hi everyone, I'm Kerem Savut. I'm a freshman student at the Department of Electrical and Electronics Engineering at Bilkent University. And today I'll present you my PHYS102 lab project. The aim of my experiment is to determine the rate of change of the magnetic flux of the coils with different number of loops by using Faraday's laws. Faraday emphasized that even though a constant magnetic field cannot create any electric current, an electric current can be produced in a conductor by a varying magnetic field. It is called the induced current. When the magnetic field of the coil varies, current flows through that coil, acting as there is an EMF source inside this coil. And he concluded that a changing magnetic field induces an electromotive force. Faraday also examined the factors affecting the magnitude of the induced EMF. He found that rapid increases in the magnetic field and the area of the circuit loop increases the EMF values. Magnetic flux's magnitude is directly proportional to the magnetic field line's density which passes through the loops. Therefore, it can be concluded that induced EMF in coils is equal to rate of change of the magnetic flux. Moreover, if circuit consists of n loops wrapped closely enough, total induced EMF must be the sum of each loop. Therefore, the total EMF value becomes minus number of loops in coils times the rate of change of the magnetic flux. And since the aim of the experiment is to determine the rate of change of the magnetic flux, this formula will be used by keeping the number of loops in coils as independent variable. Those are the equipments I have used in the project. Magnet, scientific calculator, multimeter to measure the EMF value in each stage, support bar to keep the coil at a fixed height, rulers to keep the point fixed where the magnet was dropped, in order to keep the EMF value constant, copper wires to make coils with different number of loops, a cylindrical roll to keep the radius of the coil same at every stage, and this is also something that's done to keep the EMF value constant. In this experiment, I made coils by tightly wrapping copper wires around the cylindrical rolls. After that, I dropped the magnet into the coil from the same height so that the speed of the magnet passing through the coil remained constant. I tested in 5 stages with the number of loops being multiples of 20. And at every stage, I measured the EMF value on coils by multimeter and recorded these values in the table. This is the table I've obtained after the experiment. This table contains the electromotive forces measured by multimeter after each draw and the calculated rate of change of the magnetic flux values for these attempts. As is expected from the formula, the rate of change value increases proportionally with the number of loops in coils. This is the electromotive force versus number of loops in coils graphs of 5 different attempts. As formula indicates, electromotive force divided by number of loops in coils value should give the rate of change of the magnetic flux, which is the tangent value of the baseline of this graph. After doing the required calculations, I found the rate of change of the magnetic flux value as approximately 13,21 times 10 to the minus 5 Weber over seconds. Finally, there were some errors among the results found at each stage, as seen in the table. Firstly, the winding frequency of the coils was not exactly the same at each stage, which caused the EMF value to change slightly. Secondly, even though I tried to do several adjustments to keep the EMF value constant, the measurements were made at very sensitive values, and the multimeter could not give clear results at these values. Those were the primary reasons for the errors.